Welcome to This Explainer. Today we're tackling a massive, widespread misunderstanding about the scientific words we literally use every single day. We are constantly bombarded with scientific claims, right? But they come in very different shapes and sizes. So let's break down the science of making claims by looking at a classic heavyweight matchup, theory versus hypothesis.
Okay, let's dive into this. Which of these two words actually carries more weight? Which one represents a claim that is better supported by hard evidence? Keep your own answer in mind as we start at the absolute ground floor foundation of how science actually works.
Section 1. Observations, the building blocks.
So, an observation is simply an accurate, or sometimes inaccurate, representation of a specific aspect of the world. They are the absolute essential building blocks of all empirical sciences. To kind of anchor this, picture my cat. He's got this beautifully bright ginger-colored coat. Now, if I pop him onto a scale, I might observe a weight of exactly 6.5 kilograms. Assuming my scale isn't broken, most scientists would totally accept this as a perfectly valid observation. It's just a raw reflection of a specific aspect of reality. Now, what's really interesting about this is, without any explanatory power, this standalone observation is actually kind of useless. To a scientist, 6.5 kilograms doesn't explain why he weighs that much. Observations literally only become useful when we take them to the next level.
Section 2. Hypotheses. Finding the pattern.
This is where observations actually get put to work. We are stepping up from simply seeing a single, isolated data point, like, say, a heavy ginger cat, to actively hunting for patterns in the world around us.
So what exactly is a hypothesis, anyway? Well, it's a statement that describes a pattern or a general relation between properties. Basically, it connects the dots. The plausibility of a hypothesis can range wildly, right? From entirely untested all the way to strongly supported by empirical studies. But the key takeaway is that it actively attempts to explain a pattern.
Applying our ginger cat analogy, a hypothesis goes way beyond just a single weight. We are stating a pattern here. Ginger cats will, on average, be overweight more often than cats with different fur colors. And then we extend it with an explanation. Like, maybe the genes for ginger fur and the genes for signaling stomach fullness are biologically linked. Now that is a hypothesis.
Section 3. Laws, precise but unexplained.
To demonstrate how a scientific law works, let's do a quick thought experiment. Imagine I take my cat's food ball and, just for fun, drop it from a height of exactly 56 meters.
Because a scientific law is a highly precise description, usually expressed as a hardcore mathematical equation, we don't even have to guess what happens next. Knowing the Earth's gravitational constant, we can use Newton's laws to predict with unbelievable accuracy exactly how long it takes for that bowl to hit the ground. Laws are generally incredibly well substantiated, allowing for this kind of remarkable precision.
So the crucial point is, laws have a major limitation. They give us the absolute mathematical precision between distance, time, and gravity, sure, but they rarely explain why those relationships exist in the first place. They tell us what will happen, not why. Actually, this demand for mathematical precision is exactly why you almost never see laws formulated in the complex, unpredictable realm of the social sciences. Human behavior and group dynamics they don't fit into neat equations the way a falling bowl does.
Section 4. Theories, the ultimate explanation.
Let's move to and see how this builds to the absolute top of our scientific staircase. Everything we've discussed so far, the basic observations, the pattern-seeking hypotheses, the precise laws, these are all foundational. A scientific theory is the pinnacle built solidly upon all the layers beneath it.
And this brings us to a massive colloquial myth that we absolutely need to debunk right now. In day-to-day life, when someone casually says, "Oh, I have a theory," they usually just mean an unsubstantiated guess. But in science, a theory refers to a broad, overarching explanation of many related phenomena. When you read news headlines criticizing a scientific concept as just a theory, remember that the everyday use of the word is flimsy, while its scientific reality is incredibly robust.
So how is a theory actually built? Well, in the natural and behavioral sciences, it's built out of multiple hypotheses that are very strongly supported by solid empirical evidence. In the social sciences, a theory is considered highly plausible when it's withstood rigorous attempts to completely refute it, based on logical, historical, or qualitative grounds. Theories are literally the closest thing to certainty that we have in science, simply because they consist of hypotheses that have survived brutal, exhausting scrutiny across all disciplines.
Section 5. the myth of absolute certainty.
And this brilliantly illustrates our final plot twist for today. While theories are our absolute best explanations, science doesn't actually offer untouchable truth. For example, back in 1687, Newton's mechanics ruled the scientific world as a deeply well-substantiated theory. I mean, it was accepted reality. But by 1905, Einstein's theory of relativity came along and totally replaced those mechanics. This matters because it shows us that even gold standard theories are eventually replaced, or at least refined, when more comprehensive evidence emerges. Science is entirely designed to update itself.
As our source material reminds us, in science, there is no certainty, only a provisional best explanation. This perfectly captures the ever-evolving nature of facts. Science isn't just a static list of absolute truths locked in a vault somewhere. It is a relentless, ongoing process of getting closer and closer to reality.
Knowing the journey from a simple observation to a highly vetted theory, and knowing that even our very best theories are provisional, how does this change your view of scientific facts? I hope this explainer has empowered you to rethink absolute certainty, appreciate the rigorous structure of scientific claims, and above all, always stay curious. Thanks for joining me, and keep questioning the world around you.